Hi guys again. So for this video, it's we're gonna talk about Venn diagram now. And yeah, I think I can start. So Venn diagram is like it's something that helps you with I guess the visualization of your events, right? If you want to properly visualize your events, and yeah, Venn diagram, it does a beautiful job. Ne? So you have you'd have usually they would put a square, right? You have that. I'll have another one here, right? Maybe another one here, right? And usually you would have a couple of events, say event A and B. I would do this, right? I would do this, right? And I would do this. Yeah. So this is what a Venn diagram looks like there, and you can call your events A, B, A, B, A, right? So yeah, and here, so each circle, for example, let me start with this one. This circle inside A, these are all possible events A, right? Inside B, these are all possible event B's. Good example, you have a die, right? Even A is odd number, right? Even B is even number, right? So therefore here you're gonna have 1, 3, 5. Here you're gonna have 2, 4, 6. Do you understand? And yeah, that is it. Ne? And with Venn diagram, there are a couple of things that we talk about. We talk about mutual, mutual X. We, what? So we talk about mutual exclusive events. Oh, yeah, mutually exclusive events. Mutually exclusive events, which are events that cannot happen at the same time, right? When you have events that cannot happen at the same time, we would say those events are mutually exclusive. Ne? Yeah, and this is a good example of what mutually exclusive events would look like, right? In a Venn diagram. Ne? There is no possibility of them happening together at the same time. You cannot have a number which is an odd and an even number at the same time, right? And then for diagram B, we can still use a die and say this is a what? This is a prime number. I would say prime number. Hey, prime. Yeah. So prime number and then even number. So for prime number, we have I'll say 2, 3, and 5. And then even number, we have 2, 4, 6. Yeah. So here's what's happening here. Here, ne, both numbers, they have one number in common, and that is 2, right? 2 is both a prime number and an even number at the same time, right? So what's happening? So you would say that 2 is an intersection of the two events, right? So yeah, 2 is an intersection of the two events happening, right? Yebo, intersection of the two events happening, right? And you will see that we have 3 and 5, which are not even, they are isolated, and you have 2 and 4, which is not a prime. No, you have 4 and 6, which is not a prime number, so they are isolated. And here in the common shared space between A and B, we have 2, which is both a prime number and both an even number. So that is yeah, that's our Venn diagram Daso, right? And usually for Venn diagram here at the top you would write that S equals to 6 to say we have a die that has 6 sides. So if I ask you what's the probability of having both an even and an odd, no, a probability of getting a prime number and an even, you're gonna say it's 1 over 6. Here it is. This is the intersection, right? And this is where we find and, right? Probability of prime and even number, you find them here, right? And then probability of getting prime numbers is gonna be 1 2 3. This is a circle of prime numbers and there are 3 values in it. Probability of even number is gonna be 3 over 6 1 2 3. This circle represents even numbers, you understand? And then there are numbers that are neither prime nor even numbers. Those number, one of them, it's 1. Actually 1 is the only one, so you put it outside, yeah, because it doesn't fall within any of these two events. 1 is not a prime number, 1 is not an even number, you understand? So then 1 is gonna stay outside. So yeah. So you saw when with the examples that we did, there were questions that were like, what is the probability of getting not probability of getting not orange? I remember that one, where we had a couple of balls, blocks, and there was like, what is the probability of getting not orange? Ne? So those not, we call it complementary events. Yes. So you would say, how we define complementary events, you'd say probability of a not, so you put a thing there on top, or you could just put this line to say not a, it's probability of 1 minus probability of a, right? Yeah. So if ever I could say on our example, what's the probability of getting not a die, not a prime and even, right? Probability of getting not a prime and an even, it will be 1 minus probability of getting yeah, prime and even. Yeah, just using the just using the formula, right? Yeah, just using their formula. So basically on our diagram we have 1 outside, right? So most likely the answer, it has to be what? It has to be 1 over 6, right? Because if we say not prime, not even, right, we're going to it's gonna be 1 minus, right? And in fact here, right, here it must be yeah, 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 it's fine. Yeah, definitely to be 5 over 6, which end up giving you 1 over 6. Yeah. I feel like this example doesn't clearly show what I want to show, but I am confident to get an example that does that, right? So that is a complementary event. We have also this thing. We have this thing. You see this thing that we have here. So this thing, it's for union, and this one here of n is for intersection, and then the union is also for o, right? And the intersection is for and, right? So here I can write what's happening here one, come on, awe. Here I can write this probability to say probability of A or B, right, is equals to probability of A plus probability of B, right, minus probability of A, A, and B, right? And of course here, when you transpose this guy and you transpose this man, so it's like when you do this, right, and you do this, you're gonna end up with something like this. Probability of A and B is gonna be probability of A plus probability of B minus probability of A or B, right? So know this thing, you're gonna use it a lot, right? When you go to grade 10, when you go to grade 11 and 12 as well, this is a formula we're going to use a lot, né? And so now I want us to go back to the Venn diagram and look at it as to what does an or mean and what does an and mean, right? So let me remove these. So this right here, né? This, it's the end, right? This is the end. Yeah, bro. So when we're talking about probability of A and B, we are talking about the intersection. And then when we talk about or, we are talking about this. So we have the first circle, and then we're gonna have something like this. Oh no, friend, come on. Right, I will do this. Cool stuff. So if we talk about and, né? And is, oh no, we are talking about or now. It's gonna be this whole circle, right, plus this portion of the circle, right? Yeah, so this portion of the circle is not gonna be included. So in a sense, we have let me go for red. We have A here and we have B here. Probability of A or B is probability of A and probability of this portion of B, right? And the reason is the reason we do this, the reason we have to subtract, we are subtracting, let me see, this is all, we are subtracting the intersection, right, this portion, right? Because now I think a die is a good example. Let me show you. This example we had with even and prime number, prime. So we have 1 standing outside, we have 4 and 6, this is 2, this is 3 and 5. Yeah, so let's cook. So here, probability of A or B, it's going to be probability of A, which is probability of getting what? Of getting a prime number, that is 3 over 6, né? Plus probability of B, probability of getting an even number, that is 3 over 6, né? Minus then we subtract the intersection. I will tell you why we are doing that. We only have one number there over 6. Cool. So if we don't subtract, né? If we do not subtract this, there's gonna be this thing called double counting, right? Because here on 3 over 6, 2 is included. Yeah, and here also 2 is included, so 2 is counted twice, right? But we need to count it only once. That's why we would count it here and not here. That's why we are subtracting 1 here, to say we don't want to double count. Yeah, I hope that makes a lot of sense. Cool. I think I've explained everything that needs to be understood. Let's do a couple of examples and see if we really understand what we have been talking about. Yeah, so Fiona has 85 labeled discs which are numbered 1 up to 85, ne? if a disk is selected at random, right, what is the probability that the disk number ends with 5? So we have these things then. Um I'm wondering, because this one, of course, you can do it without a Venn diagram, but I'm just wondering, I don't want to do it with a Venn diagram, this one, because yeah, there will be quite a lot of, yeah, okay, okay, we will do this one, but I'm not going to use a Venn diagram to do it. And then I think the rest, we will be able to nicely do a Venn diagram with them. But this one, no. Yeah, if you guys were in grade 11, I was gonna use a Venn diagram. It has a lot of events, this one. So grade 10, you guys only, your Venn diagram has 3 possible events. So let me cook. I'm gonna write numbers 1 up to 85. So I have written down all the numbers 1 up until 85, né? And let's try to answer this question. So of course, NS is going to be 85. Probability of getting a number that ends with 5, right? So this one, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So they are 9, so it will be 9 over 85. Remember, here they said numbers that ends with 9, not multiples of 5, né? Yeah. And then here they actually we don't even need to write all of these numbers. If you can calculate by head, you are just fine. Yeah. So for multiple of 3, right, multiple of 3, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, I'm starting to lose it here. But 3, 6. Okay. So if you count up until 30, you have numbers. If you count up until 60, you have 20 numbers, right? So from 20, yeah, oh man. Okay, let me see, let's 85 divided by 3, man. It's 28, therefore there are 28 numbers, right? Yeah, so you're gonna say the answer is gonna be 28 over 85. So 28 over 85. And then multiples of 6, let's do the same thing. 85 divided by 6, so therefore there are 14 numbers, so you will say 14 over 85, right? Multiple, the number is 65. This one is just gonna be 1 over 85, right? 85, because there's only 165. I want to move very fast here. It's a boring example. It's not a multiple of 5, so you take all the numbers that are multiple of 5. We can say 85 divided by 5. So therefore there are 70 numbers that are multiples of 5. So we then say 85 minus 17. Then you have 68 numbers that are not multiples of 5. So the answer is 68 over 85. Is a multiple of 3 or 4. You take all numbers that are multiples of 3, all numbers that are multiple of 4, calculate the probabilities of each, add them together. Right, a multiple of 2 and 6, same thing, guys, same thing.